In this video, we're computing the integral of 2 cosine pi x on the interval 0 to 2. And the main point in this video is to show how to compute this integral like a physicist. So what I mean is we're going to look for every possible symmetry that we can exploit, rather than just using a brute force method to compute the integral. And what I notice about this thing is that it's a sinusoidal function. And sinusoidal functions have a nice property that if you integrate on an integer number of periods, that integral is going to vanish. So let's compute the period of this thing really quick. I'll call that capital T. And that's 2 pi divided by the coefficient of x and the argument of the cosine there. In other words, 2 pi divided by pi. And I find out the period of this function is 2. And then I realize we are indeed integrating on an integer number of periods because we're integrating from 0 to 2. That's one period of this function. So we immediately conclude the answer to this integral is 0. So let's bring in a graph to see why this thing vanishes. So there's a graph of our function, and we see that it is indeed periodic with a period of 2. And I've shaded in the area represented by this definite integral. So the area from 0 to 2. Well, we can see in the graph, we end up with exactly the same amount of area above the x-axis as we do below the x-axis. So all the negative area is going to cancel out the positive area, and that's why we get 0 by symmetry in this integral. So you definitely want to keep this in mind anytime you find yourself doing definite integrals with sinusoidal functions. Before you start doing any hard work, just take a look to see whether or not you're integrating on an integer number of periods.